So let's talk more about wastewater treatment. Just going back to this slide here, and we had gone through a lot of these processes, kind of talking a little bit about them, and you can see that we've mostly talked about primary, secondary, and tertiary. So primary is screening and some initial settling and grit removal. Secondary treatment is kind of that mostly biological, where we're adding oxygen and we're trying to get microorganisms to basically eat all the organic and phosphates and nitrates that are in the water, and then eventually they're going to settle out. There are anaerobic processes too sometimes. And tertiary treatment, we talked about a little bit, which includes things like UV and ultrafiltration. And I had just kind of quickly mentioned the solids treatment. And so I want to go back to that and talk about that a little bit. So I think I had showed you one or two of these slides here already, but I just want to kind of revisit them and maybe just a little bit slower. So solids treatment, it kind of depends on which part of the solids. Most of that stuff at the beginning, if you go back to this flow chart here, most of this stuff here at the beginning, so toilet paper and grit and whatnot, this is mostly just sent straight to the landfill. And sometimes they dewater it. So different systems for dewatering might include centrifuges or basically squishing out the water, because of course the less water in there, the less you're actually transporting, right? But most of the solids in the secondary treatment, so those microorganisms that are settling and all that stuff, does get treated a bit more. And so we call this our solids treatment. So you can see this involves a few things, right? Sometimes there's some digestion. Like I said, the dewatering is to kind of reduce the volume, less to deal with. And disposal kind of really just depends on the plant, right? And that could include some composting, which makes fertilizer, or sometimes it's sent to the landfill. Kind of depends on what's going on there. I was really curious as to what they're doing now with this, and I'll talk about that in a moment. So here is a diagram or a photo. I think I showed you this photo here. It's kind of similar to that one of the cake, they call it. And that's the solids that have basically been dried out, and they mix it with the hog fuel. And the hog fuel is basically large, I guess you'd call it large flake sawdust. And they scoop all that together. And I'm not sure why they have sometimes inside, and they have a giant warehouse where they store some as well. But they have to leave it a certain amount of time, and it actually gets quite hot. You've got all that digestion of the microorganisms is going on. You've got all this fermentation going on, and it actually heats up. And can't remember if I have a slide on this or not. Let me see here. Somewhere in my notes, I probably have my notes in my office at the college, but it has to reach a certain temperature for a certain amount of time.
Blaine?
Yeah.
Will it be dangerous to touch that hog fuel?
The hog fuel is just sawdust, basically. So it's not dangerous.
You said it's going to get very hot. So.
Okay, very hot. No, I mean, it's not super hot. I mean, it's getting up to maybe 60 degrees in some cases. And that's not enough to burn you. It's just enough to feel.
But is it like it's not poisonous though, is it?
No. Now the cake is going to have microorganisms in it. And what I was getting at is it has to reach a certain temperature for a certain amount of time. And I can't remember what that temperature and how much time it is. But the reason why it has to do that is because those temperatures will kill any parasites in there. So I think most parasites actually get killed around 50 degrees Celsius, not a very high temperature. So as long as they reach whatever that minimum is, it will kill the parasites, as long as it's at that temperature for a certain amount of time. So this is part of the composting, and like they add some fuel in there, and the mass actually reduces. So during some of the composting, some of the organic matter is broken down into carbon dioxide, and that is going to reduce the mass of the whole thing. And basically, in the end, they end up with with some fertilizer. It doesn't smell. It just looks like something you might buy at the garden store. I was hoping to get a photo of that and this year, because sometimes they have a bag of it to show off. And you can see I found this diagram on the internet of somebody here doing this with an outhouse at a low, just in a low volume kind of thing here. Sorry about that. And it's the same idea with this composting. I think they're actually adding some sawdust or sometimes just other organic matter, so like leaves and nutshells and things like that. And it looks like they're collecting it and probably using it for fertilizer. So this is their initiative. They're calling it Northern Roots Compost. And this is a relatively new thing, and I don't know why the website is now not functioning anymore, but you can check out that video if you're interested. It mostly just talks about how they're using our waste. They're making compost, and it shows a little plot of land in Fort McKay where they're doing some reclamation work, and they're using that as fertilizer. One of the women I was talking to there said she brought a bag home, and her rose garden apparently is just amazing now. So I'm not sure if they're actually doing much more with it. Last time I talked to them, I think was 2 years ago, and they basically said the plan was to start selling this stuff, but they weren't doing it yet. So I don't know why it was taking so long, whether there's regulation around it or whether they just didn't feel it was worth it at the moment in terms of the economics. But they said basically at that time they were donating a little bit. Some people were taking some home for their gardens, and most of it was going to the landfill at that time. So that was 2 or 3 years ago that I had a conversation with them regarding the compost. But there are some places, I'm trying to remember where it was. I think it was one of the big cities in Saskatchewan. I can't remember whether it was Saskatoon or Regina. They're selling it, and yeah, lots of people are buying it. So like I said, as long as it's done safely and it's cured properly, it's not really a risk for anything. It's basically just fertilizer. I mean, obviously don't eat it, but all the pathogens, if it's cured properly, are not going to be there anymore. They're going to be dead.
So it's not dangerous to touch.
No. It's just like I said, it's just like a bag of fertilizer that you get. It looks a little bit like, let me just go back to some of these pictures here. Not quite that dark. It's a little bit lighter than this cake in color, and it just looks like a dry, fine kind of soil or dirt or something like that. And you'd mix it with your normal soil because it's very, very rich in nutrients. So this is kind of a summary showing some of these processes. You can find all sorts of these little nice graphics on the internet. This one I thought was kind of cute. You can see there's the homes. There's the screening at the beginning there, and a grit tank. Like I said, the grit tank, you can really just think of it as the gravel and stuff like that that gets picked up along the sewage lines. It's just given a chance to settle. Sometimes there's further settling tanks, and you can see sometimes there's lots of floaties. And at our wastewater treatment plant, they inject some air into the system at this point, and it causes some of these things to float, and they can skim it off. And that's actually usually one of the first things that we see at that point. Step 3, they're adding the oxygen and encouraging the microorganisms to grow. You can see there's some clarifiers in there allowing them to settle. And you can see we've got our later steps where we're adding UV. Chlorine, like I said, isn't that common because then we're polluting the water, and then it's going back to the river. Over here, we've got some more solids and other digestion going on. You can see we've got a digester here. This is usually an anaerobic system. And some of these solids, it looks like, are going to a landfill. Some of them are being used as fertilizer. And the last little note I think I mentioned last day is that this anaerobic digestion makes methane. And methane is, of course, natural gas. And a lot of places are starting to actually use that as fuel for heating and producing electricity. We're not doing that here yet. I don't think we produce really that much methane. That was another question I was hoping to ask them about, but I think I mentioned that in the Edmonton Gold Bar station, apparently it's saving them $1 million a year in heating and electricity costs. So That's pretty significant. I wouldn't mind $1 million. Here's another schematic. So same idea. You can see we've got the settling out here. You can see I like this one because you can see that the liquid is here and the solids are settling out. So these are the bacteria that are and protists that are getting fat and dense, and so they're going to go and get treated here in the digester and composting, and then you've got more settling going out here, more sludge, and then the final treatment again depends on the system. In Fort McMurray, we're looking at UV kind of in that stage as well. Looks like in this system they got some sort of chemical going in. I'm not sure what that's all about, but it could be pH adjustment or some wastewater. They do add some alum to it, but again, I don't know what they're trying to represent there. So I wanted to just show you a couple of real plants, talk about the plant here in Fort McMurray a little bit. This is one in Kentucky. You can see the chlorination here. Like I said, I'm not aware of any plant in Canada that does that. But I guess they feel that it was necessary in Kentucky. It's also possibly it's older systems that do this. Like I said, this takes a lot of land, a lot of time, and then you have to dechlorinate the water before you put it back into the system. So that's kind of a problem, right? So here's Saskatoon, and I actually have a video of the Saskatoon plant I'm going to show you. And it's pretty good because it's actually very similar to the Fort McMurray system. And so hopefully you can get an idea of what's going on. It's actually relatively well narrated, but you can see they're showing one of the, it looks like they have chlorine there as well. I didn't realize that, but I'll play the video for you in a moment. But you can see they've got some round clarifiers. They've got these bioreactors. So the bioreactors are just where the bacteria is and they're adding oxygen. The DAF thickener, that's kind of at the beginning where they're adding the air and skimming things off of the surface. And they have these big digesters in Saskatoon because they have a lot more farm waste they're dealing with, which means a lot more cellulose. And so they need those these big anaerobic digesters. So I'll play this video for you. And it's not too long, but hopefully you get an idea of what's going on there. And it's, like I said, it's relatively similar to our plant. I'll click on this link here, load this up. Okay, I guess I gotta share other, where is it? There we go.
Did you know over 90 million liters of wastewater is treated every day at Saskatoon's wastewater treatment plant? That's enough to fill 36 Olympic-sized swimming pools. So what exactly is wastewater? Wastewater is any combination of water and waste that is flushed down your toilet, sink, or tub. This wastewater eventually ends up in the South Saskatchewan River. But before it gets there, it's treated at the wastewater treatment plant.
We use some of the most environmentally sustainable and up-to-date treatment processes at the plant to protect the people, property, and the environment downstream.
So how does wastewater get to the wastewater treatment plant? Wastewater flows from the sinks and toilets in homes and businesses and from industries in the community into an underground maze of pipes called the sanitary sewer system. Saskatoon's wastewater collection system is about 1,050 kilometers long, approximately the distance to Edmonton and back. A gravity system and 28 pump stations located throughout the city keep the wastewater moving. Once the wastewater reaches the plant, an extensive and complex treatment process begins. Over 200 pumps and mixers and over 50 kilometers of internal piping, enough to stretch around Saskatoon Circle Drive twice, help the wastewater travel through the plant. In the first stage in this treatment process, the wastewater passes through a series of screens to remove materials larger than 12.5 millimeters. These materials are cleaned and transported to the landfill. The wastewater then travels to large basins where heavier materials, called sludge, settle and sink to the bottom. Lighter materials, including fats and oils, called scum, float to the top. The sludge and scum are sent to fermenters and digesters, where bacteria breaks it down further. During this process, methane gas is produced, enough to heat about 390 homes each year. We use this methane as fuel to heat the buildings and certain processes at the wastewater treatment plant. Any excess methane is flared. The sludge, about 5,600 tons per year, is pumped into storage cells and used as fertilizer on nearby farmland. The remaining water from the primary sedimentation basins is pumped to another process where nutrients like phosphorus and nitrogen are removed using naturally occurring microorganisms. In 2013, Saskatoon became the first city in Canada to recover this phosphorus and nitrogen and use it to create a product called Crystal Green, an environmentally responsible and extremely efficient fertilizer. Finally, the wastewater passes between ultraviolet lamps, sterilizing any remaining parasites and bacteria, such as Cryptosporidium, E. coli, and Giardia, before the water is deposited back into the South Saskatchewan River. Our treatment process ensures the final wastewater does not harm our precious river and downstream users. Back at the plant, all aspects of the treatment process are closely monitored 24 hours a day, 7 days a week by highly trained plant operators. Our on-site laboratory performs about 30,000 analyses each year to ensure continuous quality control, record the plant's performance, and monitor the environment. We're also prepared to expand our operations as our city continues to grow.
We have a 30-year long-term capital development plan and the capacity to ensure effective and efficient treatment for a population of about 500,000 people.
Protecting people, property, and the environment. These are the priorities of the wastewater treatment plant. For more details or to learn about our environmental initiatives, visit saskatoon.ca.
Okay, so I hope you enjoyed that. It's not as good as the real thing, obviously, but I thought it was a pretty decent overview of what's going on there. And you can see, like I said, they do sell their fertilizer there. And I'm not sure why we're behind the curve on that one. Could be market demand or something like that. I was hoping to get a bit more information on that. I know they're pushing forward, and I know our the regional municipality is they've got all sorts of green and sustainable initiatives going on. It's a little hard to keep track of what all they're trying to do, but it's encouraging to see that they're trying to do some of these things. So I want to just talk a little bit about ours. I know I have been a little bit kind of on and off here, and just kind of say a little bit what's going on in the regional municipality. So we do have some rural areas in Fort McMurray, the regional municipality. So rural areas include Fort McKay and Anzac, and these places have mostly their water treatment is lagoons. So I mentioned the lagoons last day are basically these ponds. And the ponds are just open places for the wastewater to go in and allow the natural, sunlight and natural oxygen and organisms to kind of do their thing. And when you have small populations, these are reasonably effective. You can see they have a treatment lagoon and they have a retention pond to allow a little bit more settling. And then there is monitoring. That was another thing I was going to ask them about too, because I had heard rumors that they were going to be upgrading the Anzac systems. And my understanding is there was some issue that has happened after the fire, that those plans have been delayed and all that. So I was looking for more information on that. And I guess unfortunately it didn't happen. So Fort McMurray, up until I think it was 08 or somewhere between 2008 and 2015, I can't remember, used to basically be mostly lagoons. And so the system we were going to see on the tour is very, very new. This is, again, this is from a website. They used to have the municipality, an interactive website that kind of showed the process, and you can see, in the picture form, all of that happening here, right? So you've got the water coming in at number 1. Number 2 is the solids going to the landfill. You've got some clarifiers. You've got these bioreactors. This is the big part of our system where you're just adding oxygen and allow microbes to do their thing. We've got some compost, some secondary clarifiers, and UV at the end. So there's the overview of it and a little bit of information about it. So it's about 25 megaliters a day. And I can't remember how much it is that they do in the springtime. So now it's a little bit more with all the runoff. They end up having quite a bit more water as the meltage runs into the system, particularly from downtown where it's a combined sewer system. So they're getting all the stormwater as well. So I think I showed you this picture before, talking about what we're going to see in the tour, but you can see some of those systems there labeled. And number 4 being the bioreactors, where they're adding the oxygen to encourage the microorganisms. So what else was I going to say about our facility? This was a flow chart that was going to try to explain what was going on. Don't worry about too much of this flow chart. It makes a lot more sense when you've actually been on the tour. But one thing I wanted to mention was this here. And they like a lot of acronyms. And so when you go on the tour, you see all these acronyms everywhere. And this was one of them that I wanted to talk about. And I'd already mentioned already, DAF stands for dissolved air flotation. And this is something that happens right near the beginning, where they inject all this air into the system and basically skim off whatever floats on there. And so, often people have a lot of questions about what exactly is going on there and what DAF stands for. Often what happens on these tours, people write down some notes and they come back with a bunch of acronyms and they can't remember what the acronyms are, because they sure like them in this industry. So there's an image of the DAF. This is a relatively smelly place. Like I said, it's kind of early on in the system, and you can see all those solids are floating and basically getting skimmed off. So I want to show you some images. One year they did this for me. It was very nice, and it was basically water samples taken at different stages along the tour, right? So you can see what the water looks like. So the influent, it's not clean, it's a little cloudy. And after they basically do the grip tanks and the toilet paper, you're getting this primary, that should say influent, not effluent. It's not too bad looking. In the bioreactors, you have all those microorganisms growing, and a lot of them are pigmented, and so it looks very brown. The secondary clarifiers, you can see there's a little bit of settling out. There's still some solids in there, but by the time it settles out, it basically looks like this. It's very clean. In fact, it's cleaner than the actual river water, which is just really incredible. Every time I see that, I'm just amazed how efficient the system is.
Blaine?
Yes.
Do any of these water samples have a sort of odor to them?
That's a good question. I never did smell them. I think these are the typical water samples they take because they're measuring all the parameters in the lab as they go along to make sure that their systems are working properly, right? So I think these are pretty typical water samples they're taking out, and they're measuring all the things that you guys were measuring in the labs, right? So solids is a big one, pH and conductivity. They're also measuring
turbidity.
Yeah, turbidity. Yeah, in fact, the turbidity they don't have to do in the samples because they have built-in turbidimeters along the way. And I'll show you what one of them looks like. I got a photo here coming up, and basically it's all digital and gets fed right into their computer system. So there's one of the stations, right? So I'm not exactly sure what all this station measures other than turbidity. But basically, some water is going through this in a tube, and it's measuring a couple of different parameters. And they have a bunch of these around the station for taking track of this. So this is the one that was basically at the very end of the tour, and right before the water is about to head to the river. And I wish I would have zoomed in on that and taken a photo of the reading. But so I can't tell you what the turbidity was of the water on the way out. So I had also mentioned this gold bar plant in Edmonton, and it looks a lot like the Fort McMurray one, except for it's just bigger. So you can see, you know, for example, you can see you've got these digesters here. They've got like, I don't know how many, it looks like 8 there maybe, compared to the 1 we have in Fort McMurray. You've got all these bioreactors here. They're just larger scale, and more bioreactors over here. And so, you know, it's Edmonton, right? They're servicing a lot more people. So about 800,000 people this plant is servicing. They do have another plant somewhere in Edmonton. I'm not exactly sure where that was, but this is kind of the main one. And why it's called Gold Bar, I don't know, but this is run by a company called EPCOR. And it's worth it to mention EPCOR because I've actually run into a couple of these people. I'm trying to remember where that was now. And they actually mentioned that they hired some Canada students at one point, and that they thought that the environmental students here were pretty good. The one guy I was talking to at EPCOR, maybe it was on this tour because I had gone on a tour of this place. And he was actually mentioning that they had hired some students from SAIT, and they were basically had a diploma in water quality, which was great. But he said he really liked the Canada graduates because you guys have exposure to a lot more things. And so, you know, he had valued that as well. So if you're ever looking for employment, look into these guys. I know that they have hired in the past. I don't know what's going on in the present, but you know, something to look into as a, if you're interested in this kind of thing as a potential career. So this is their graphic showing what's going on. And like I said, it's very similar to what's going on in Fort McMurray, just at a larger scale. You can see there's the pre-treatment and the grit removal. You've got that little truck and the solids going to the landfill. And I don't know what this enhanced primary treatment is here. I guess it's some chemical addition, and I can't remember all the details on that. But you've got the secondary treatment. You can see they've got bioreactors. That means they're adding oxygen. You've got sludge is just going to go to solids treatment. Some of the solids treatment goes down here to anaerobic digestion. And you can see over here, this is the methane being produced and producing electricity and heat. They also have UV disinfection at the end, just like us. And the one thing that I had mentioned was a big feature of this place was this filtration system. And this filtration system, the water was being used by Suncor for their refinery processes. So I think I showed you the picture of that membrane filtration system before as well. Okay, so there's a few other things to talk about in terms of what is going on in Canada and Alberta. Obviously, not everybody has, they're not living in a town or a city, right? So this was my parents. They didn't have an outhouse, but they had a septic tank. And so I just want to talk a little bit about what's going on in these systems here. So this includes a lot of farms, people just living out of city limits. You know, one solution, and I have friends who live on Draper Road in Fort McMurray here, and they don't have a septic field or anything like that. They have a tank, and there's somebody who comes and collects their waste once a month or whenever they need it, I guess, and that gets shipped to the wastewater treatment plant. But a lot of places have septic fields, septic tanks, and things like that. So I just want to talk a little bit about what these things are. So an outhouse, if you've ever used one, you know, is basically just a hole in the ground, and when it fills up, often they bury it. Sometimes they pump it out. Kind of depends on your situation. So that's kind of the old classic method. I think in Canada, you're not technically allowed to build new outhouses. If you have one there, you can keep it, kind of thing. So there's a lot of cabins and cottages that might have this kind of system. Same thing with septic tanks. I think septic tanks, you're not necessarily allowed to add new ones if you have an existing one. So my parents had one, and it was in the backyard, basically buried maybe a meter under the garden. And basically it's a tank with holes in it. So the way it works is your waste goes there, and the water can basically come out of the tank and get mixes with the ground there. You know, in this case, it was under the garden, and the solids basically are going to ferment inside the tank, and And once in a while, I'm not even sure how frequently, because I don't really remember it happening that often, it gets dug up and pumped out. And that is basically how a septic tank works. Most people who have these systems now have to put in what's called a septic field. And so septic field is kind of like a septic tank, but then you have this distribution system over a certain amount of land that can bring the water. So this is just the water getting put into the ground, and you've got microorganisms in there that are going to eat it all up. And as long as you're not contaminating someone's drinking water or anything like that, this is basically the system how it works. So you can see the water is getting distributed to kind of an underground gravel bed is basically what is going on here. Sometimes these have to be cleaned out and pumped out once in a while. Again, I don't really know too much about that. I should ask my sister sometime. She lives at a lake, and her home has a septic field, so maybe she knows a little bit about whether there's any maintenance at all. I don't really know.
Blaine,
Yes.
not to offend anyone who lives on the farm or something, but or on the country, but how would working with water, like how would they actually do it? Like would they have to like filter it out or something? Because it seems pretty complicated.
You mean for the drinking or for the
Well,
for the waste?
for both, like for all uses.
So my parents had a well, and there was no treatment done to it whatsoever. It was basically the water was pumped into the well. The well itself, I think the pump in the bottom of the well had a filter in it, but we never had any issues. The water was, for the most part, really clean, other than the fact that some seasons it was discolored. My sister gets her water directly from the lake, and she literally has a line that goes into the lake, and it's kind of off to the side where nobody's using it. Maybe it's under the dock. I'm not exactly sure where the line is. No treatment there either, but her lake is super clean. It's like spring fed and all that. But
Okay,
I've seen
so she won't get sicker or something?
No, I think she's had it tested a couple of times, but it always comes back pretty clean. I was going to just say, I know someone else who lives on a lake, and this lake has a lot more algae in it. And some of the family members, maybe they're allergic. When there's a lot of algae, they feel like their throats gets a little itchy when they drink the water. But for most purposes, the water's fine. So in that case, what they do is, those jugs you can get at Safeway or the grocery store, the 18-liter jugs, they just buy that water and truck it up for drinking, and then and then the lake water can be used for other things, dishes.
Yeah, Blaine, because I had a teacher in high school who lives near Gregoire Lake, so I just want to like ask, like, I wonder how people who live near the lake or on a farm would be able to use their water.
Yeah, I think it's a case-by-case system. Gregoire Lake is not too bad depending on where you're at. Some places have more algae than others, but it's worth to ask. Out of curiosity, because I mean, it's an essential thing. We need water, but the wastewater itself, like I said, is going to a septic tank or a septic field in most cases, and then it's basically treated by the microorganisms that are found in underground.
Okay, so as long as it's treated right, there's no that your sister and all that can safely drink the water and use the water as long as it's treated right.
Well, this stuff here you're not going to be drinking. It's basically going into the ground, and if you have a well, it's going to probably be way on the other side of the house. And these are usually, deeper and kind of. I mean, there have been certain situations where people have had these things and they're kind of uphill, which is not good because it'll go down and then possibly drinking water. But I think the general design is it's in a place away from where you're obtaining your drinking water, and the water just becomes part of the groundwater. And like I said, the microorganisms in there clean it up. Okay, what was I going to say about this? Yeah, and this is just saying that, a lot of places wastewater is transported, so picked up by trucks, and then often brought to a lagoon or wastewater treatment plant. So there's a lot of places around here work camps and whatnot. And this is the system. And I can't remember how many trucks they said they have arriving daily at the wastewater treatment plant in Fort McMurray, but there's quite a few. And trucks just carrying this stuff, and then it gets treated at the plant. So I wanted to show you this. This was a pretty interesting video here, and it was done through, I think it was through a grant through Bill Gates's charity. And you can see at the end here, so what they're doing is they're cleaning up wastewater and making it drinkable and doing a bunch of other things with it. And it's kind of a cute little video. And of course, everyone wants to see Bill Gates drink wastewater. So I'll share this with you. Let me just get that screen up. It's a short little video, and you can see what they're doing with their wastewater. But this is, a little bit of the future, us trying to figure out how to do a better job of recycling and reusing our resources. And in some places, Canada, we have so much water, but in many places in the world, we don't. And so wastewater technically is a resource. And so I'll play this for you, and you can see what they're doing in that.
Over 2.5 billion people have no access to safe sanitation. We asked brilliant engineers to help us solve this problem. And one of those engineers actually has proposed a solution where the waste is valuable.
The Omni processor turns sewer sludge, which is kind of nasty, into clean drinking water, electricity, and ash that is pathogen-free. This is where the sludge enters the machine. It goes up this conveyor belt, is fed into these large tubes we call the dryer. That's where we boil the sludge. And in the boiling process, we separate the water vapor from the solids. The solids are now dry, and we can feed them into the fire. Once we have this very hot fire, we can make high pressure, high temperature steam. And we take that steam and we send it to a steam engine. And the steam engine drives a generator that makes electricity that we use for the processor, and also excess electricity that can be delivered back to the community. The water vapor that's created in the boiling process is run through a cleaning system until we have the cleanest, purest water you can possibly imagine.
The sanitation system as we know it in the developed world cannot work in developing countries. So what we need in developing countries is a very simple system.
The entrepreneur that owns this processor will get paid for the input, the sludge. And that same entrepreneur will get paid for the outputs, the electricity, the water, and the ash.
I am very impressed with this solution we're seeing here. It generates electricity, it generates clean water.
It will grow to every corner of the earth that needs it because it makes money every day.
It's water.
I kind of wonder if Bill was a little hesitant there at the end. Thought that was funny. But yeah, like I was saying, I think this is in some ways the future, right, of us trying to figure out how we can recycle our resources. Like that guy at the end there had said, we're going to need different solutions based on where we live in the world. And if you think about what you've got there with wastewater, you've got water, that's a great resource. You have potential fertilizer, and we're so rich in Canada, we don't feel like we need these things, but a lot of countries are realizing that no, there is a resource here that can be recycled. And so I thought that was kind of a cool video showing a solution for it. I don't know whether these things are operational at the moment or anything like that, but at least one engineer came up with a prototype, and so maybe we'll see more about this in the future. So I had some study questions here. I'm going to just let you look at them for the exam. I'm not going to finish now. I want to kind of move on with this. I'm just looking at where we are with the calendar. And at the moment, unfortunately, I'm a little bit behind, and I do want to have some review time for the final exam. So I'm looking at some options for doing that. And what I might do is have an optional review session next Thursday morning. I know classes are supposed to be done on Wednesday, so that's why it will be an optional review session, but I do want to cover the last topic, which is talking a little bit about air quality. So let me just switch to that, and we'll do a little introduction on air quality here. And we'll come back to this next day. So what did I do with it? There we go. Okay, so let's talk about air quality. There is a ton we could say about air quality, and I'm trying to keep it into basically 2 lectures as a somewhat of an introduction. And I think maybe future versions of this class, we're going to expand this a little bit. But at least you guys benefit from having a little bit of this. And probably you've learned a little bit about at least climate change in Neil's class last semester. So I want to touch on that as well as kind of an important aspect of air quality. So first of all, let's just go through some definitions. We're going to be talking about the atmosphere. And the atmosphere, of course, are the gases that surround Earth or other places. Notice it says moon. Does anyone know, does our moon have an atmosphere? Does anyone know?
I'm not aware, probably.
It might, but it's probably like very thin. Like
Yeah,
very
so
thin.
I Googled that today and I got different answers. So I'd like to know something a bit more definitive about it. It doesn't have much gravity, the moon. It's like 1/6 of Earth. So that means a lot of gases will escape into space. I did find one article that said it does have a very thin atmosphere, but not of like the typical gases. It said, I think it had like some sodium gas or something weird like that, or potassium gas. I don't even know what that is. So I didn't have enough time to really look into it, but I thought that was kind of interesting. Apparently Mars has a very thin atmosphere. If you guys have been following the recent Mars rover that they've landed, one of the cool additions is the rover has a little mini, I don't know what they're calling it, drone or whatever, that can fly around. And of course, you need to have an atmosphere if you're going to have little helicopter blades to fly this thing around. So Mars does have a thin atmosphere. So the atmosphere includes all sorts of things. Obviously, the air we breathe, which is the thing we're most concerned about, and but it includes you know, things that are involved in weather, the aurora, and so on. So I think air quality is an important topic to learn a little bit about. It's very complex. I'm not going to go into all of these things. I don't really know a lot about the different levels of the atmosphere, but you may be familiar with some of these names: the troposphere, stratosphere, mesosphere. Meso means middle, so I guess that's as middle as it gets. And the thermosphere is actually pretty big. It goes up to apparently 350 miles.
Blaine, a fun fact about the thermosphere is that that's where the aurora, that's where the northern lights happen.
Yeah, and that I knew. And I know it's very thin up there, obviously, going up to 350 miles. So imagine that's as far as we measured gases. It would be my guess, but I'm not 100% sure about that. Yeah, I was hoping to see the aurora again, but winter seems to be disappearing now, so we'll see. So what is in the atmosphere?
Well, the aurora doesn't really follow the seasons. It's brighter, but
No.
they can happen anytime.
Oh yeah, I know that, but I mean, with winter disappearing, it means that suddenly we're going to have light until like midnight, and you know, you have to really stay up late if you really want to see it. Is the problem, right? So what's in the atmosphere? You probably know that the big components are nitrogen and oxygen, and actually argon is another of the major components. So this is like 99.something% of the atmosphere. Notice I call it the dry atmosphere. There is water vapor in the atmosphere, but that really varies all the time depending on the season and, you know, where you are on the globe. Sometimes the air can be quite saturated with water, and sometimes it's almost 0%. But if you kind of look at an average, it's about 1% of the atmosphere globally. There's all sorts of trace things in the atmosphere. The biggest one is carbon dioxide, and that's one of the things that we want to talk about. But all these other things, you can see some noble gases, neon and helium, a little bit of methane in there, krypton and hydrogen gas are all components of it as well. And obviously there are other things that are found in even smaller concentrations, although they could be higher depending on pollution and industry in the nearby areas. And we'll talk a little bit about that next day. So question, is carbon dioxide a pollutant? Any thoughts on that?
Well, it's not really a pollutant. We actually need carbon dioxide to like absorb the sun's rays. It's like, it all depends on how much is in it. Like,
Yeah,
it.
very good. I think you hit on that. So it's definitely a natural part of the atmosphere, and it's required for plants to do photosynthesis. And we produce it as animals, we produce it as part of respiration. Another way to think about it, and that was the second part you said, it kind of depends on how much, right? So this is a definition from a textbook about what pollution is, and it says higher than the normal ambient levels. And so it kind of depends on what we really mean by that. But most people nowadays agree that there is more carbon dioxide than maybe there should be. And so it is technically considered a pollutant, right? Just sort of in that aspect, and that there's more than perhaps normal and desired. So I wanted to show you this kind of regarding climate change. It's a little cartoon I found, and because I see this all the time, right? You know, that every winter it happens. We have, you know, -40, and somebody makes a comment about where's that global warming, hey? And you can see this second person with the black toque and saying, this used to happen all the time, right? And then he or she is saying to the other person, you're from St. Louis, right? So you can look at these average temperatures, right? And sometimes it gets cold, and that's normal. This is called weather. Weather, it gets hot, you've got cold days. It has nothing to do with climate in some ways, because climate is long-term trends, right? So you can see, again, talking about those polar vortexes and how it feels cold today, but our memories are so short, you know. I can tell you, by the time I get to January, sometimes I forget how warm it was in the summer and the other way around. And we're Canadians too, right? So that means we, you know, it's our right to complain about weather because we have lots of crazy weather too, right? I think weather's funny. My mom was big on looking at weather forecasts, but you can see there's the future, and there's a puddle or some ice, and he says so much for global warming. So sometimes it's just one of those conversations that people they don't want to think about long-term stuff. But here's some definitions, right? Weather is kind of your day-to-day stuff, all the things we look at in the forecast: how much rain, how much snow, how hot it is, you know, all those kind of things, right? Climate is the sort of the long kind of general what is going on with those variables such as temperature.
So Blaine, would climate be
those kind of things?
So would climate be like a more general, broad version of broad term?
Think of the tropics, Fahad.
Yeah, what were you saying there, Brandon?
I said, think of the tropics for an example.
Yeah. So it's
So
the
like,
long-term trends in the weather, right? So you can say, for example, in Fort McMurray, you know, between, let's say, June and August, you know, we get an average of this much rain, obviously plus or minus with a little bit of standard deviation in there, and that's kind of what climate is. And so, well, the second part of my definition is what is change in climate, right? And that's where we see differences. So, you know, maybe the trend was 30 years ago, we had this much precipitation, and now over the last 10 years, we have less. And so that would be climate change. Usually we're talking about long-term stuff. With climate, usually we're not talking about less than a few years, more like 10 years, and definitely comparing it to some sort of baseline, which could be 50 years ago, 100 years ago, that kind of thing. So this is the thing that people get really confused about, because the day-to-day weather, of course, changes, and this is what we're really good at observing. You know, I remember today, yesterday, I can't remember Friday. I mean, you know, this is the human brain, right? I can't even remember what I had for breakfast yesterday sometimes. But if I were to record that, then I could see these trends, and I could see that, okay, with my breakfast, you know, I eat a lot of toast, for example. And that is a trend. With climate, we can look at temperature and rainfall. Okay, so I think this is a good place to finish. I was going to talk a little bit about some of the data we have, but I guess I'll leave that for next day. Anyway, thanks for coming. So I guess our next lecture is on Monday, and I'll be on campus, or at least that's the plan for Monday. So I hope you're all doing well, and we'll see you next week.
All right.
Great, thanks.